So, we trust AI with so much these days our finances, our healthcare, you name it. But what happens when these super smart systems start to get things wrong? That's what we're diving into today. A huge, often invisible problem that can make even the best AI models fail. Let's get right to it.
Right. And this really is the key question, isn't it? I mean, you can train an AI model to be perfect, absolutely flawless, based on data from the past. But here's the catch. The real world, it never, ever stands still. It's always changing. So the big question is, how do these systems keep up? And maybe even more important, what happens when they can't?
Okay, so to really get a handle on this problem, we've got to take a quick look under the hood at how a model actually learns in the first place. And really, it all boils down to two key ideas: features and labels. All right, first up, let's talk about features. The easiest way to think about them? They're like the ingredients you give to a chef. They're the clues, the raw data, the pieces of info the AI has to work with. So if you're trying to predict, say, a house price, your features would be things like the square footage, how many bedrooms it has, where it's located. You get the idea. These are all the measurable inputs. And then you have the label. Now, if the features are the ingredients, the label is, well, it's the final dish. It's the correct answer you're aiming for. So for our house example, the label is the actual price it's sold for. What the AI does during training is it looks at all those features, all those ingredients, and tries to figure out the recipe to get to that one correct label. It just keeps trying and trying, getting better and better at it over time. Okay, so you do all this work. You train your model on millions of data points, and wow, it's amazing, it's incredibly accurate, you're ready to go. But the real problem starts the second you set it loose in the real world. Because out there, the data looks nothing like the clean, perfect stuff it trained on. And this right here, this is the absolute heart of the problem. See, the data an AI learns from, it's like a perfectly posed photograph, a clean, structured snapshot from a moment in time. But the real world? Oh, that's like a chaotic live video feed. It's messy, it's unpredictable, and it is always changing. And it's in that gap, that chasm between the training world and the real world, that things really start to fall apart. This slow decline in a model's performance has a name, and it's called model drift. Think of it like a slow, silent erosion of the model's smarts. Its accuracy just starts to decay over time, simply because the world it's living in now doesn't match the world it learned about. And this is so important. It means you can't just build an AI model and walk away. It's not a one-and-done thing. It needs constant maintenance. So model drift isn't just this one big, vague problem. It actually breaks down into two main types. You can think of them as the two key culprits that data scientists are always on the lookout for.
So, there are basically two ways a model can go off the rails. First, you've got data drift. This one's pretty easy to wrap your head around. The inputs, the features themselves change. The what you're feeding the model is different. But then there's concept drift, and this one is a lot sneakier. With concept drift, the inputs might look exactly the same, but the meaning of those inputs, their relationship to the final answer, has changed. It's like the rules of the game have been completely rewritten without anyone telling the AI.
Okay, let's make this super concrete with some real-world examples. For data drift, picture a credit scoring model that was trained on data from before the pandemic. Then 2020 happens, and suddenly, everyone's spending habits are completely different, right? The inputs have totally changed. That old model, it has no clue what normal spending looks like anymore. Now, for concept drift, think about the idea of a risky loan. Let's say new government regulations are passed. The person applying for the loan might have the same income, the same debt level, all their features are the same. But because the rules have changed, what those features mean in terms of risk is now fundamentally different.
So, if these models are always in danger of drifting away, what do we do? How do we stop it? Well, the good news is data scientists aren't just sitting back and watching it happen. They've got a whole toolkit full of strategies to build and, just as importantly, maintain really robust AI systems. This whole fight against drift, it really happens on two main fronts. First, you've got to be proactive. You have to think about this stuff during the model's development phase, building it to be as tough and stable as you possibly can, right from the get-go. And then second, once it's out there in the real world, the job's not done. You have to constantly keep an eye on it, monitoring and adapting as things change. So, back in that development phase, teams use some seriously clever tricks to build stronger models. For example, they'll check which of their input features are actually stable over time and just toss out the ones that are too unpredictable. And they even use this cool technique called adversarial training. It's basically like giving the AI an immune system. You intentionally throw curveballs at it and try to trick it, all so you can find its weaknesses and fix them before it ever sees the light of day. And, it's not just about these practical strategies. Underneath it all, there's some really deep, cutting-edge science going on. We're talking about researchers who aren't just putting band-aids on the problem. They're fundamentally rethinking how to build these models from the ground up to make them naturally resistant to change, right from their core. Okay, now you're going to see a pretty intense-looking formula on the screen. And let me just say, you absolutely do not need to understand what this means. Seriously, don't worry about it. The only reason we're showing you this is so you can get a feel for the incredible scientific rigor that goes into this stuff. An equation like this is basically a recipe for optimizing a model not just to be accurate today, but to minimize how badly it can mess up when things inevitably change tomorrow. It's literally about building mathematical stability right into the model's DNA. But like we said, the work doesn't stop when the model goes live. Oh no, it's an ongoing process. Teams set up these automated dashboards that are constantly tracking performance, and they'll get an alert the second accuracy starts to dip. They use all sorts of statistical methods to catch drift as early as humanly possible. And, maybe most importantly, they schedule regular retraining sessions with fresh, new data. And they work side by side with human experts who can actually explain why the world is changing and what it means. So after all that, you might be wondering, why does all this technical, behind-the-scenes work matter so much? Well, it all boils down to one single, incredibly important word: trust. Think about it. We are handing over more and more critical decisions to AI systems every single day. We're talking about models that help diagnose diseases, or decide if you get a loan, or even guide a self-driving car. For those kinds of high-stakes decisions, the predictions have to be reliable. There's no room for error. And fighting model drift is absolutely essential to making sure these systems stay trustworthy in the long run. And this quote you see here really just nails it. Getting a model to be accurate right out of the gate is great, sure. But that's not the whole story. Real, long-term reliability comes from robustness. And that robustness is built on a foundation of stable, consistent features, the kind that don't get completely thrown off track by all the chaos of the real world. So when you think about it, as we rely more and more on AI, the biggest challenge is shifting. It's not just about making them smart based on the data of yesterday. The real trick, the real challenge, is keeping them wise enough to handle the messy, unpredictable world of tomorrow. And how we figure out that puzzle, how we manage that continuous learning, that's what's going to define the entire future of trustworthy AI.